Picture this, your Claude-powered application is running smoothly, users are happy, and then suddenly everything crashes. Not with a bang, but with a whimper. No error messages, just silent failures. That's what happens when you ignore error handling in Claude systems. Today, I am going to show you the exact system I use to prevent these disasters. Your Claude API calls are quietly failing, and you are paying for it. Have you ever noticed that your Claude app simply stops generating halfway through? Or that you pay for tokens but get no usable response? Token limit errors do not yell, they just cut off silently. The key insight is these are service-level failures, not code bugs, which means you will never catch them with a typical try-except block. The real danger is that you might not even realize it's happening. You'll see a partial, unusable response and think your own logic failed. Meanwhile, you are burning credits for abandoned requests. This silent failure mode forces you to build detection for something you can't directly trigger. The key insight is that this error appears successful, leaving you with a structurally valid but dangerously incomplete response. What this means is your system will process this partial data as truth, creating downstream failures you cannot trace back. This isn't just data loss, it's a silent corruption that compromises every decision built on that flawed output. Your API keys silently expire on a schedule, but your code does not get a polite error. Instead, it gets a ghost response. This isn't an API hiccup. It is a total system failure masquerading as a correct answer. What you are left with is operational blindness, where your application confidently proceeds with a lie. Your Claude app will fail, and this hidden API bug is why. And your app accepts this empty silence as valid data. The result: critical workflows break downstream. Customer transactions fail without explanation. You lose revenue while logging systems show everything as successful. That's the danger, perfect-looking logs that mask catastrophic system failure, letting problems multiply until they are far too expensive to fix. So then, how do you even detect this? The data looks fine. The logs are clean. Yet your business logic is paralyzed. This is why partial completions are so insidious. They satisfy every automated check while delivering absolutely zero operational value, creating a ghost in your machine that only reveals itself through customer frustration and stalled processes. These retry loops become hidden financial drains. Each failed attempt isn't just wasted compute, it is a cycle consuming resources, degrading performance, and inflating your bill with zero forward progress. The key insight is that a single unhandled error can trigger an exponential cost spiral, quietly burning through your budget while the system appears to be functioning normally. That subtle, deprecated flag in an API update isn't a suggestion. It is a ticking time bomb. Your application continues to run, silently switching to a less efficient, more expensive model. You are paying more for degraded performance without a single alert. This isn't an oversight, it's a direct, stealthy profit mechanism for the provider. Your Claude app has a silent money leak. I can prove it. Right now, errors in your API calls are invisible. They're costing you money and breaking user trust without a single alert. The interceptor solves this. It automatically wraps every single call to Claude, trapping failures before they escape. This gives you centralized control. Every error is captured, logged, and handled, turning chaotic failures into managed events you can actually fix. Now, logging alone isn't enough. You need a tiered system for interpretation. Debug logs show raw details for engineers. User logs translate errors into friendly messages to maintain trust. Admin logs provide the operational summary you need for quick decisions. This separation is what turns raw data into actionable intelligence for everyone on your team. But everyone gets this wrong. They add a simple retry and call it robust. Exponential backoff isn't just a delay, it is a strategic retreat. The system intelligently concedes to overwhelming traffic, preserving your API quota and your budget. This patience under fire is what separates a fragile script from a resilient application. Now, the silent killer, cost overruns. You cannot fix what you do not see. True monitoring isn't passive logging, it is an active sentinel. It identifies a cost per call trend, projects it forward, and intervenes before the financial damage is done. This isn't an expense report, it is a strategic shield, protecting your budget in real time. You are leaking API credits and do not even know it. But do not just retry everything. For some errors, that's like throwing money into a furnace. The recovery matrix gives you the strategy. For a 5xx server error, yes, perform an immediate retry. That failure is probably a temporary network blip. The server could recover in milliseconds and you just saved the call. But for other errors, retrying is pure waste. The pattern clearly indicates a rate limit. An immediate retry would only make the problem worse and trigger harsher penalties. Instead, your system must adopt a strategic pause. This intelligent waiting respects the server's constraints, signals you as a good citizen, and dramatically increases the likelihood of a successful, cost-effective request on the next attempt. But a strategic pause only works when the problem is temporary. What if your primary model's outage is severe or prolonged? This is your moment of escalation. The recovery decision matrix instructs you to have a pre-configured, less expensive fallback model ready to take over, ensuring your user's workflow continues seamlessly without you ever paying a premium for downtime. Now, you face the ultimate strategic decision. Does this error require immediate developer attention, or can the user be informed to proceed? The matrix draws that critical line. A timeout is a user notification, a complete model failure is a developer alert. This separation keeps your team focused on fires, not false alarms. Your Claude apps have a silent financial leak right now. Think of a fire alarm versus a fire. One warns you to exit safely, the other causes panic and chaos. Your app's response to failure is exactly that choice. Graceful degradation provides that alarm, letting the core functionality deliver value while clearly signaling what's broken. It keeps trust intact when things inevitably go wrong. Imagine hitting submit only to watch your entire form reset. That lost work directly translates to lost revenue and frustrated users. A robust error handler saves progress automatically, turning potential abandonment into a seamless retry. It's the silent guardian ensuring no user effort is ever wasted. Now compare that frustration to this moment of clarity. Your user gets a simple, honest message, so they understand the state of the system without feeling confused or abandoned. This transparent communication builds immense trust. It confirms their request is still being processed, just managing expectations and keeping them confidently engaged in the experience. But a graceful failure requires more than just a message. Your user is stuck. This is your moment to lead. The key insight is to immediately provide a practical alternative. When the automated system fails, offer a clear, manual path forward. This turns a dead end into a simple detour, preserving momentum and keeping the user firmly in control. Your Claude app has a fatal flaw silently draining funds now. This is the final piece, a self-contained defense module. We have moved from theory to actual production code. This class integrates every handler we have designed, transforming isolated fixes into a unified error management system. Your application now actively protects its own integrity. Deploy this, and you are not just running code, you are enforcing a security protocol for every single request. Think of this middleware not as a filter, but as the final checkpoint. It wraps your entire app, intercepting every single request and response. The pattern clearly indicates a shift from reacting to anticipating errors. Here's what's really happening. Your application now runs inside a managed execution environment. This is how you enforce stability as a core, non-negotiable feature. But this is still reactive. You need to see the attack before it lands. The key insight is that you must transition from a war room to an observation deck. What this means is instrumenting your checkpoint to broadcast telemetry. This visibility is what separates a defensive posture from true operational command. Yet, automated testing remains a defensive strategy. You are still waiting for the system to fail. What this means is you must anticipate the failure that no one has ever seen. The pattern clearly indicates you must inject controlled chaos to expose hidden fragility before real users ever encounter it. Claude errors are silent and expensive if not handled proactively. A proper error layer saves money, prevents crashes, and improves UX. Your error handling system should make decisions, not just log problems. Implement the error handler from today's examples in your next Claude project.